All right, everyone. So this video is going to be the beginning of Unit 5, Lesson 1. Balancing chemical reactions is something that, in theory, you learned in physical science in middle school, but as we all know, for a lot of you this year, physical science was your 8th grade year, and that is when COVID hit. So there are a lot of things that kind of slip through the cracks. So in Unit 5, it's gonna end up being a combination of Unit 1 and Unit 4. So you're going to see a lot of those elements, beginning with the law of conservation of matter. So this is kind of a review of what we did in the first couple of weeks of school. So you hopefully remember that matter is anything that has mass and volume, okay, which we use to solve for density, right? But mass, it has weight, made up by the protons and neutrons and electrons, and volume, it takes up space, and it's made up of these tiny particles called atoms, which we learned all about in Unit 2. And the law of conservation of matter says that matter cannot be created or destroyed. Okay, so matter cannot be created or destroyed. It can only be rearranged or transformed. Okay, so our atoms cannot be created or destroyed. That means in a chemical reaction, we break the ionic and covalent bonds between the atoms and the molecules, rearrange them, change up the order, form new ionic and covalent bonds, and create new substances. But because they cannot be created or destroyed, that means that there must be the same number of atoms on each side of the reaction. Okay, and so to balance the chemical equation, you must add a coefficient to the front of the chemical formulas in the equation. You cannot change the subscripts, because remember in Unit 4 we learned that when you're solving for an ionic compound, or not solving, when you're writing the formula for an ionic compound, those subscripts are based on being able to balance the positive and negative charges between the cations and the anions. And so our coefficients represent the number of molecules that are in the reaction, while the subscripts represent the number of atoms of that particular element in that molecule that's like inside it. And so we're going to review this and kind of show what that looks like in this chemical equation here, which is a synthesis reaction, aka marriage. So if we look, you're going to need two colors. So if you have like pens around you or colored pencils or something like that, or you can do shapes. So I'm going to do a green circle to represent aluminum, and I'll do a yellow box to represent oxygen. That way we know whether we're using colors or not colors, the differences between them. Now here in aluminum, remember this S in parentheses, that means that the aluminum is a solid, and the G means that the oxygen is a gas. So those are not elements on the periodic table that we're looking for. Here we just have aluminum, which is going to have a subscript 1 that chemists are kind of lazy about. So that means I'm going to draw just one aluminum circle. And oxygen has a subscript 2, so that means that I have 2 of these boxes bonded together, which kind of merge into one. So I'm going to put an outline around them. Okay, so we have 2 of the boxes. And then for aluminum oxide, Al2O3, we're going to have 3 oxygen atoms. Okay, and I'm going to put my aluminums in the middle of them. Okay, so we have this molecule. Now currently I have 1 of each. I have 1 aluminum, 1 oxygen molecule, and 1 aluminum oxide molecule. So that means my coefficient, okay, because these numbers here are all your coefficients. okay? And remember, these little numbers here, like the 3, that's a subscript, okay? So currently, I have one molecule, or one aluminum atom, one oxygen molecule, which has 2 oxygen atoms in it, and one molecule of aluminum oxide, which has 2 aluminums and 3 oxygens in it. Now, when we tally up this, okay, currently we have 1 aluminum, 2 oxygens on the reactant side, and 2 aluminums and 3 oxygens on the product side. Remember, reactants, they're on the left or the beginning. Products, they're on the right side or at the end of our reaction. And this is not balanced. It looks like I started with 1 aluminum and magically created a second atom of aluminum, or that I started with 2 oxygen atoms and now I magically have 3 of them. Okay, that doesn't work. And so what we need to do is balance the reactions by increasing the number of molecules that we have. So currently I can say, all right, well, let me balance aluminum. There's 2 on the right side, 1 on the left. That must have meant that I actually started with 2. So if I put a second molecule, I can change my coefficient to a 2. And so we see that we multiply our coefficients by our subscript. So 2 times my 1 subscript is 2 aluminums, and they're now balanced. And oxygen, however, is still not balanced. I have 2 and 3. Now, unfortunately, even if I add another molecule here of oxygen, okay, which would look like this, that changes this to a 2, but 2 times 2 is 4. That still doesn't really fix it. So what you have to remember is that when you're balancing and you have an odd-even situation, you're probably going to be looking for the least common multiple. So we know that, excuse me, I'm a little sleepy. We know that the number 2, so we're looking at our subscripts, the subscript 2 and the subscript 3, the number that they have in common is 6. So if instead of having a 2 in front of oxygen, I put a 3, I know that 3 times 2 is going to give me 6 oxygens. So that means I'm going to have 3 molecules of O2. So I've got to have that represented in my picture. And then if I have a 3 there to make it a 6, I'm going to need 2 molecules of this. Now, when I have 2 molecules of it, right? So I'm drawing just my second exact molecule, okay? That doesn't mean that I now have 2 plus 2 is 4 aluminums or anything like that. We know that 2 times 2 aluminums is 4, and then 2 times 3 aluminums here is 6. So these numbers down at the bottom, those are just representing our totals. And so now we can see that it's completely balanced. Oh wait, no it's not. Our aluminums are not equal. I have 2 on the left side and 4 on the right side. So that tells us that instead of having a coefficient of a 2, where I have 2 singlet or single aluminum atoms, I'm going to need 4 single aluminum atoms to start with. Because if you don't have this ratio, 4 aluminums to 3 oxygen molecules, in order to make 2 aluminum oxides, then the reaction won't happen. You have to have the correct ratio between the ingredients or between the chemicals in order for a reaction to happen. So let's take a look at this in just like a balancing problem. Well, 2 balancing problems where we're not also having to draw a particle diagram. Okay, so when we're doing a balancing problem, the first thing that you want to do is kind of split your reaction or your equation into your reactants and products. So remember your arrows, that's where your reactants, which are on the left side, and your products, which are on the right side, are separated. It's the beginning and the end, the before and after, okay? And then you may list what elements you have. So here we have magnesium and we have oxygen, just 2 of them. And we'll count our initial amount. How many do we have to begin with? Well, we know there's an invisible 1 here as a subscript, so I have 1 magnesium and 2 oxygens on the reactant side. And again, invisible 1s as subscripts, so I have 1 magnesium and 1 oxygen. Now, my magnesium is balanced, but oxygen is not. So in order to balance it, I have to ask myself, what can I multiply by this 1 in order to get it to be a 2? And the answer is a 2. If I put a 2 here, 2 times my 1 oxygen is 2 oxygens, and 2 times my 1 magnesium is 2 magnesiums. So it balances oxygen, but it doesn't balance, or it unbalanced my magnesium. So I'm going to have to increase the amount of magnesium on my reactant side. Again, if I'm trying to decide what can I multiply this subscript 1 by to make it balance out, the answer is a 2. 2 times 1 is 2. And now magnesium is the same on both sides, and so is oxygen. Now what that tells you is since there's no number in front of oxygen as a coefficient, that's a 1. But again, chemists are kind of lazy, so most of the time you're not going to see a 1 there. It'll be a blank space. So hopefully you found that relatively easy. Now, example number 2, what I want us to look at here is this one is a combustion reaction. It's got only carbon, hydrogen, and oxygen, and it's going to be a little more complicated. The reason why is because oxygen is in 2 different places on the product side. So it can be kind of tricky, and we're going to have to pay attention. So if we split our reaction again, and we write down, we have carbon, we have hydrogen, and we have oxygen. So let's keep track of these 3 elements. So on the left side, we have 2 carbons, 6 hydrogens, and 2 oxygens. And on the product side, I have 1 carbon, 2 hydrogens, and I have 3 oxygens because I have 2 oxygens here plus the 1 oxygen over here. So that gets me 3. Now keep in mind, those oxygens are going to be the ones that get you in trouble. So pay close attention. I also recommend balance oxygen last. It'll normally make your life easier. So in this case with carbon, we have 2 on the left side, 1 on the right side. So if I put a 2 in front of carbon dioxide, there's a invisible subscript 1. So 2 times 1 is 2 carbons. 2 times 2 makes this side 4 oxygens plus that 1 over there for a total of 5. So we can say, okay, carbon is balanced on both sides, but what about hydrogen? There's 6 on the reactant side and only 2 on the product side. So I'm going to need to put a 3 in front of here. So 3 times 2 is 6, and 3 times the invisible 1 here is 3. So that means 4 plus 3 is a total of 7 oxygens. And again, that's where it's going to be tricky because you might want to say, oh, 3 times 5 is 15, or maybe you're multiplying by these numbers down here, but remember, it's always multiplied by the subscript, okay? So these numbers are the ones that get multiplied. Now, we're in a little bit of a dilemma, and I hope you might be able to see it. Here we have a 2 and a 7 for oxygen. Now, even if I put a 3 there, 3 times 2 would be 6, or 4 times 2 would be 8, it would not give me 7. So my tip to you is when you have an odd even split like that, where you can't figure it out, multiply the coefficients by 2. All of them. Because remember, anything multiplied by 2 always becomes an even number, and then that'll make it a lot easier. So remember, currently there's a 1 right here. So it's invisible, but it's still there. So instead of having a 1, we're going to multiply it by 2. And our 2 will become a 4. And our 3 will become a 6. So let's update our totals. 2 times 2 is 4. 2 times 6 is 12. Oxygen stayed the same. 4 times 1 is 4. 4 times, or let's do hydrogen next. 6 times 2 is 12. And then oxygen. 4 times our subscript 2 gives me 8. 6 times my subscript 1 is 6. And 8 plus 6 is 14. And now I say, oh, if I have 2 on the reactant side and 14 on the product side, I can just put a coefficient of a 7 here. And then 7 times 2 gives me 14. Now, when you're looking at your practice, I arranged your practice in order from level 1 being your easiest type problems to level 4 being the most advanced. I actually put a very hard problem in level 1. Well, it's not difficult. It's just intimidating because it has really large coefficients. So I'm going to give you a hint if you're watching this video about your practice. This coefficient is supposed to be a 10. So what you can do is I want you to pick what level you feel the most comfortable at. So level 1, looking at synthesis or decomposition reactions. Level 2, you're looking at single and double replacement reactions. But notice these are all binary compounds. All of the compounds are binary. You don't have any polyatomic ions because level 3 is going to be your combustion, which was example number 2, or ones that have polyatomic ions. Now, I'm going to give you a hint. Number 6 is a great example of this. Also, I forgot to put a little line here in front of BaSO4. But one thing you'll notice is there are lots of parentheses, right? We have polyatomic ions that are on the back of our periodic table. So we have NH4 in both places. We have SO4 in both places. And we have NO3 in both places. And the beauty of this is it allows us to be able to keep our polyatomic ions together. So I can say, all right, NH4 is one of my ions, SO4 is another one, Ba is a regular cation, and NO3 is one of our polyatomic ions. So now, when I'm counting up how many of each of them I have, remember that when there's no parentheses around it, that's like a 1. So remember, if I have NH4 2, that SO4 doesn't have parentheses, so if it did, it would look like this. It would be SO4 with a 1 outside of it. So that's saying on the left side, I have 2 NH4s, 1 SO4, 1 barium, and 2 nitrate ions. And on the product side, again, when there's no parentheses around your polyatomic ion, there's just 1. So I have 1 ammonium, 1 nitrate, 1 barium, and 1 sulfate. And so we say, okay, this becomes pretty easy. I'm dealing with 1s and 2s. Those numbers are easy to manipulate. So if I take a 2 and I put it in front of ammonium nitrate on the product side, that means I'm going to have 2 NH4s, and I'm going to have 2 nitrates. And that 1 coefficient fixes everything. So that means all these other ones are 1s. So what was looking like a very intimidating problem, when you keep your polyatomic ions together, it actually becomes much easier. And so that is my hint for you. Now, if you decide to jump to the level 4 problems, the balancing part is not more difficult, but you do have to change from the names to the formulas in order to get an equation to balance. And remember, you have to think about your diatomic elements when you're writing these formulas, and they can be remembered by just saying Hofbrinkel or by saying have no fear of ice cold butterbeer, because y'all are in high school, so it's butterbeer. All right, so have no fear of ice cold butterbeer. That can be your phrase. Another way is if you look at your periodic table and you find nitrogen, there are 7 diatomic elements. And if you start at number 7 on the periodic table and you draw a 7, you get nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And so this 7 on the periodic table is the 7 polyatomic ions plus hydrogen, which is over here. So you just kind of have to remember that one. But there are multiple ways to remember. And the reason why is because if you look at number 2, in order to do this, we're going to have to balance out, or to write our formulas first. So aluminum bromide has aluminum, which is a metal, so this is ionic, okay? And if you don't remember how to write formulas, I suggest going back into the Unit 4 section. But it's ionic, and so we know we're going to have charges. So we have aluminum that has a positive 3 charge. Bromide, IDE, means we're talking about just regular bromine, has a negative 1 charge. Okay, so this means to balance out our charges, we're going to have bromine minus 1, bromine minus 1. So that means my formula, so I'm going to put a space for a coefficient, will be AlBr3. And then it says plus chlorine gas. Now, chlorine is just Cl, but chlorine is also one of our diatomic elements here in this list. So that means when chlorine is all by itself, it's actually going to become Cl2 with a subscript, and that's because, again, that it's diatomic. Now, the word yields, that's our arrow, okay? It's saying it means to make, okay? To yield, to make. And we have aluminum chloride, which is also ionic. So I have Al plus 3, Cl minus 1. To balance it out, I'm going to need 3 chlorines. And so we get AlCl3 plus our bromine gas. Bromine is just Br, but bromine is also one of my diatomic elements, and so it has to be written as Br2. So now that you've gone from the name to the formula, you can actually balance, which in order to balance this, you would need to make the 2's and the 3's become 6. So you'd need a 2, a 3, a 2, and a 3 in order to balance. But you can take a look at whichever practice level you feel the most comfortable at right now, but you want to make sure that you're progressing and working up to a level 4 because you're going to have a problem like this on your test. So let me know if you have any questions, and good luck.